We spend so much of our lives trying to filter out noise, right? We're always trying to find that one clear signal. But what if, for the most powerful processor on the planet, your brain, all that static, all that chaos isn't the problem? What if it's actually the solution? In this explainer, we're diving into the wild idea that the noise we've always ignored is exactly what our brain has been listening to all along.
Think about it. In all of our technology, noise is the enemy. It's the static on the radio, the fuzzy grain in a photo. It's that interference we're constantly trying to get rid of. We see it as this messy obstacle that gets in the way of what's important. But when it comes to the brain, is that really the whole story?
And this is where we see this incredible clash of ideas. On one side, you've got conventional thinking, which says noise is just junk, a problem that needs to be filtered out, period. But a new theory from neuroscience completely flips that on its head. It suggests that noise isn't random static at all. It's actually a rich signal, packed with information. It's this ocean of choices that the brain has evolved to swim in. This brings us to a huge paradox at the very heart of brain science. When we actually measure the electrical activity inside a living brain, we find something just astonishing. There's a massive amount of noise, way more than the signals we'd expect to find. Now, according to the old way of thinking, our brains shouldn't be able to function. They should be completely lost in their own static. So that's the million-dollar question, isn't it? If your brain is this chaotic electrical storm, how do you manage to form a single coherent thought? How do you make a decision or recognize a friend's face? It's a puzzle that has stumped scientists for ages, but now we're finally starting to uncover some pretty incredible answers. So the answer starts with this radical idea, a complete reframing of what noise actually is to the brain. Instead of seeing it as something getting in the way, we have to start seeing it as a resource. This whole idea is captured in something called fractal information theory, or FIT for short, and it basically says that the brain doesn't see noise as a bug, it sees it as a feature. FIT suggests that the brain is actively using the complex, chaotic structure of noise to become more sensitive, to process information more flexibly, and to adapt to our constantly changing world.
This quote from the research really just nails it. Don't think of noise as static. Think of it as this vast, sprawling ocean, just teeming with possibilities. Every single random fluctuation is a potential path, a different option for the brain to consider. The brain isn't trying to shout over the noise, it's surfing it, expertly picking out the waves of information that actually matter.
Okay, so this is a fantastic theory, but is there any actual proof? Well, this is where things get really fascinating. A recent experiment put this idea to the test by looking at how different kinds of sound, some really structured, some totally chaotic, affect our ability to think. So the setup was pretty simple. Researchers had people do some tough cognitive tasks, like math problems and pattern recognition, while they listened to two totally different types of audio. One was really structured and repetitive, like a simple, predictable beat. The other was completely random and non-repeating, like the complex sounds in ASMR or even just pure white noise. The big question was, which soundscape would help the brain work better? And the results were completely backward from what you'd expect. The random, chaotic noise, the stuff we'd normally call a distraction, it actually enhanced cognitive efficiency. People literally performed better. But the simple, repetitive beats, they made people perform worse. The ordered sound actually diminished their brain's efficiency. So the big takeaway? Chaos was helpful, and order was a hindrance. So why on earth would that happen? Well, the theory is that all the rich, complex information and random noise gives the brain that ocean of choices we were talking about. It keeps the brain flexible and engaged. A simple, repetitive signal does the exact opposite. It's too predictable. It actually creates a kind of sensory overload and disrupts the brain's natural, much more complex way of thinking. Okay, but how could scientists possibly see any of this happening in the brain? Well, observing this relationship with noise took more than just new theories. It required a revolutionary leap forward in technology, a whole new way of looking at the mind. You see, for over a century and a half, our main tool for watching the brain in real time has been the EEG. And don't get me wrong, it's been incredibly valuable, but it has one huge limitation. It's slow. It basically gives us still photos of brain activity, but it completely misses all the ultra-fast stuff happening at much deeper levels.
And the leap in technology here is just staggering. A traditional EEG measures activity in milliseconds, but this new technology called a Dodecanogram or DDG measures it in nanoseconds. We're talking up to terahertz frequencies. So if the old EEG gives us a snapshot, a single photo, the DGG gives us the entire high-definition movie, revealing processes that were totally invisible to us before. Just let that sink in for a second. The difference isn't 2 times faster or even 10 times faster. It is 9 orders of magnitude faster. That's a leap of 1 billion times in bandwidth. For the very first time, we aren't just seeing the brain's slow, conscious thoughts. We are seeing the ultra-fast symphony of subconscious activity that is the true foundation of our minds. And once you can see these incredibly fast processes, you have to start asking much, much bigger questions. What if the brain isn't just a biological machine? What if it's tapping into something much more fundamental? This has led to a really mind-bending theory that consciousness is literally woven into the fabric of the universe through an architecture of time. It's called the self-operating mathematical universe theory, or SOMU. And what it proposes is that our minds are tapping into a universal structure. The idea is that consciousness is built from this massive network of interconnected clocks all ticking at different speeds, from the slow rhythm of seconds all the way down to the ultra-fast beat of picoseconds. So this completely forces us to rethink what the brain actually is. It's not just some biological computer that processes ones and zeros. No, instead, it's a symphony of time. It's this incredible assembly of countless clocks, all nested inside each other, processing reality across a huge spectrum of timescales all at the same time. It is a fundamentally different way of thinking about thinking itself. And what this really means is that consciousness isn't a thing or a specific place in the brain. It's a structure. It's a dynamic, ever-changing architecture that's built not out of matter, but out of time itself. Which brings us right back to where we started. If the noise we've been trying so hard to filter out for centuries is actually the richest signal of all, it forces us to ask a really profound question. What have we been missing? What hidden messages, what deeper layers of reality have our brains been trying to show us all along in that beautiful, chaotic static?